I'm Dave and I'm your host. Today we're going to talk about COVID-19, the simulation tutorial that we've made, and how you can go through that and learn a little bit about the changing the rate of people staying at home and see what effect that has on the spread of the virus. So the first little tutorial game we're going to go through will be about COVID-19 and stopping the spread, and that is right here on our dashboard. So you want to click that game, stop the spread, and the tutorial will load up here. COVID-19, stop the spread. There are many factors that contribute to how a virus spreads. And if we increase how many people stay at home, we can see what effect that has. Or if we have no one staying at home, we can also see what effect that has. And there's a good link to an article here from the Washington Post that we were influenced by when making this little tutorial. So let's go. Okay, so we've got the level loaded up here. We can click play to see what the game looks like. And we've got all our little simulated dots. These are people, right? The idea of this simulation is time's going along. We can see the days increasing. We can see how many people are healthy, how many people are sick. A whole lot of people just got infected. When these simulated people touch each other, if they're infected, they will infect the other person. And we can also see this hospital here. This is the rate of hospitalizations. And if it hits a certain point, if it gets too high, that means the health system is overburdened and people will start dying unnecessarily. People that could have been saved, if there just aren't enough beds, then they'll die. Now, running this simulation, this curve, see the shape of that curve? Over time, the amount of people that get infected, it's pretty high by doing nothing. Now everyone is recovered at this point. But that's a pretty dangerous steep curve right there. So what we can do is affect how many of these collisions happen between people by changing the simulation rate of how many stay at home. And we can also see there's a bit of a news ticker going along down the bottom as well, which we'll look into. But first, let's look at the staying home percentage rate. So if we close the game here, we're going to modify the spread factor. So let's right click on that 0% and edit that script. Okay, so what's going on in here? Well, this is saying when it's created, it's giving it a tag population staying at home. And that tag, you don't need to worry about that. That's just so that the rest of the simulation knows that this is a number that it's got to be worried about. And this is a comment telling you to change this number here, this global variable number here, community staying at home. This is the important thing for us to tweak. It's currently at 0. That means out of all our little dots, 0 of them are frozen in place. We want to try bumping up that number. Let's see what happens if we have 100% of them all locked down. Now, you know, that might be a little unfeasible in the real world, but let's see how that plays out. And we can see each infected person, after a certain amount of time passes, they will recover. And so that one infected person started out, and it really didn't have much opportunity to bump into anyone else because everyone was frozen. Now, can we get away with doing this? I guess time will tell, but staying home 100%. Let's see what it looks like if we try 20%. So there's still a bunch of people moving around. And remember that curve. Let's see what it looks like this time. Bit of an outbreak starting to happen. Whoop, pretty steep here. Hospitals flashing at us. 20%, that curve looks pretty similar to the previous one. I don't know if that was enough. Now remember, it's just a simulation, but it can be helpful for us to get an idea of how things can play out. Let's try 50. Okay, so there's a lot less movement. Still a bit of an early outbreak though. Sometimes this kind of thing can be luck. Now, is it quite... looks like we've hit the peak right there. So, as far as this model goes, 50% might have been a winner. You've still got enough activity going. Okay, well that's how you can... and you can have a few playthroughs of that. Sometimes it'll work out differently because there is randomness to how people move in real life, how they operate, and how these simulated people move as well. They get random velocities to move around it. So if you modeled this a bunch of times, you could see, you could kind of get an average. But this is a much steeper earlier curve than the one that we just ran. So that might be a fun little experiment to try. And thankfully the hospital never hit its peak there. Okay. So that's how we can change how many people are modeled to stay at home. Now, what's the next step here?